p.407. Fractals mean self-similar, and they have a table of the snowflake there. Okay, if you look at the snowflake, what they're doing there is they're taking, they're taking this triangle, and they're going to replace the middle third of each triangle, each side, with an equilateral triangle. Okay, so they're adding to this in the middle. They're dividing this into thirds, and they're making another equilateral triangle on each side. Okay, so in the table it says, in stage number 0, our edge length is just 1 unit. And we have 3 edges, and we have a perimeter of 3. Well then, when we've done this, it says our edge length is 1/3. That's because the edge here, the first edge, is 1/3 the distance that we started with. We started with this whole distance here. Now it's only 1/3 of that. Okay? And then this edge is also 1/3 of that. And this edge is also 1/3 of that, because this is an equilateral triangle you drew there. So 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3. And that's how they did. The edge length is 1/3. And then we have 1, 2, 3, 4 on each side. Let me do that in different colors so it's easier to see. 1, 2, 3, 4 on each side. And how many sides do we have? 1, 2, 3. So there are now 12 edges. And our perimeter has become 4. Because 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 thirds is 4. Alright, then they're going to come back and they're going to do the same thing again. They're going to divide each side in 1/3, and they're going to put an equilateral triangle at each side. Okay, and that's what they've done. If you look in the book, that's what they've done. Okay, that means along each side, I'm going to get a different color. Well, first of all, what length is it? Well, if this was 1/3 and we've got 1/3 of 1/3, that's 1/9. So each edge is 1/9. I'm going to have to use a stronger color than that. I can't use highlighter. So we've got 1/9, 2/9, 3/9, 4/9, 5/9, 6/9, 7/9, 8/9, 9/9, 10/9, 11/9, 12/9, 13/9, 14/9, 15/9, 16/9. Okay, each side has 16/9. Now the question, 1/9 is the length of each side. There you go. Okay. Now, the number of edges. Well, we found that there were they've done 12 times 4. Okay, 48. What I would have noticed is that this is 16 along each side, and 16 times 3 is 48, so we have 48 of them. Now what they're looking for is a relationship. What did we do to the 3 here to get the new number of edges? Okay, we multiplied times 4. And what did we do here? 12 times 4 gives us 48. Or 44 times what gives us 48. So each time, to get the number of edges, we're multiplying by 4. That would be because each edge that we had, okay, when we had an edge here and we drew a triangle in it, we came up with 4 more sides. And we had to do that times 2, 3, 4. So we went from one side or one edge to 1, 2, 3, 4 edges on each of our four surfaces. Okay, so we're multiplying it times 4. Alright, and then to find the perimeter, we're going to take our 48 edges and we're going to divide by 9, and we get 5 1/3. Alright, then when we do it again, Okay, you see what's happening to the denominator of each one here. Let me get all these the writing out of the way. Okay, here the denominator is 3. Now it's 9. We squared it to get 9. Now we've cubed 3 to get 27, or we've multiplied times 3 again. Okay, so whatever stage we're in, when we're in the 0 stage, that was the very first one. Whatever stage we're in, if we went to stage, say, 6, then each side length would be 1 over 3 to the 6th. And the number of edges would be 3 times 4 to the 6th. And the perimeter then would be 4 to the 6th over 3 to the n minus 1, which is 5, 3 to the 5th. Okay, and what they're doing, the table helps you to figure out what's happening to the numbers. Okay, so let's look at some of the things it asks you to do. It says, perimeter, find the ratio of the edge to the length of the triangle in stage 0. Find the ratio of the edge length of the triangle in stage 0 of a Coke snowflake to the edge length of the triangle in stage 1. Okay, the edge length is 1/3. What is the ratio of 1/3 to 1? You should be able to figure that one out. All right, now it says use the Cantor set, which is a fractal whose iteration consists of dividing a segment into thirds and erasing the middle third. Now this one's going to be kind of fun. I know y'all think you're crazy. You think it's fun. Okay, let me go to a clean sheet. Now it says we're going to take a segment and erase the middle third. Is that what it says? Yeah. Dividing a segment into thirds and erasing the middle third. Of course, I'm eyeballing this, but you guys have a ruler, so you should use it. So I'm going to erase the middle third there. I should have drawn the first one and kept it so that you could see it. Okay. Now I'm going to take each of these, and I'm going to copy them down here so you can see them, and I'm going to erase the middle third of those. Now I'm going to rewrite each of these. And I'm going to erase the middle third of those. Well, that wasn't a very good one, but okay, you get the idea. And it says, draw stage 0 through stage 5 of the Cantor set. Okay, this is 0, 1, 2, 3. Wow. 1, 2, 3, 4, 5, 6, 7, 8. Come back through here with an eraser. I got to make that eraser really small. Whoops, I did not mean to make it into a pen. Okay, we're going to blow this up really big. Oh, it erased the whole thing. Small. Oops. Far enough. Okay, now I've got a... No, I think it's the rest of it's over here somewhere. Okay, there it is. Now you should be doing this all pretty and straight. Oh, look at that. There's a little weird edge there. Okay, that should be right. Yep, that's stage 4. And then stage 5 would look like... Let me see if I can even get this small enough. I've got the smallest one I can get. I can't even make it small enough. You get the idea. Okay. Then it says make a table showing the stage number and the number of segments. We can do that. Okay. A table showing the number of segments. So stage 0, 1, 2, 3, 4, 5. Okay, at 0 there was 1 segment. And at 1 there were 2 segments. And at stage 2, there were 4 segments. And at stage 3, you can see how that works. Then it says the segment length. Well, if this is a whole length, then the whole length for the first one was 1, and 1/3 for the second. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the segment length was 1/9 for the third stage. And you go on from there. And then it says the total length of the canter set. Number of segments. Oh, we forgot the number of segments. No, I got the number of segments. Okay, segment length, and then the total length of the canter set. So this one is 1, and this one is 2/3, and this one is 4/9. Okay. And then the total length of the canter set. So when you get to the end, you're going to add all of those numbers up. And you get the idea. Okay, so looking at the next one, the next part of it, it says a Sierpinski carpet starts with a square side length 1 unit. At each stage, divide the square into 9 equal squares with the middle square shaded a different color. Okay, so this will be fun too. So you're going to kind of divide this into ninths. And then you're going to shade this. I need a big fat one. There's 2 points. Let me make it fat, because I don't want to be drawing all day long. Then it says, at each stage, just divide the square into 9 equal squares with the middle square shaded a different color. So now I'm going to change that back to 2, lest I walk into class and try to write with that. Okay, and then I'm going to take each of these and divide these into ninths and shade this a different color. Okay, and then when I do the next stage, how many stages am I supposed to go through? Stage 3. So 0 was the first one, and I'm at the second one. And they're not going to make you do a whole lot of these because it's going to get really hard to do pretty quick. Time consuming. Make it nice and neat. Okay, and go on with that. And then it says, explain why the carpet is said to be self-similar by comparing the upper left-hand square to the whole square. Okay? Alright, the converse of the Pythagorean theorem. Draw a triangle